Okay, let's give you guys an example. So in this video, we're going to try to determine if this series will converge or if it will diverge. So to do this, we are going to make use of this theorem, which we've already seen in the past, but we are going to make use of part 3. So we are going to make use of this. But let's just pretend you didn't know this. Okay. So let's start all over again. We are trying to determine if this series will converge or if it will diverge. When n gets very big, this thing here is just going to act like n squared because you're adding on an amount that's next to nothing. The numerator, when n gets very big, you're adding on an amount that's next to nothing, so you can pretty much ignore it. It's going to behave like this. So cancel this. That will then give you this, and then well, this thing here, if you look at the natural log, graph, natural log looks like this. This will be 1. When it's e, this will be 1. So beyond e is 2.7. So 3 onwards, this will be bigger than this. So 3 onwards. Hang on, you've got this thing here. Hang on, bear with me. So you've got this thing here. So this is 1 over n from n equals 3 to infinity, and then you've got this thing here. Hang on. Natural log of n over n equals 3 to infinity. So beyond 3, natural log will always be bigger than 1. Natural log will always be bigger than 1. So we know something about this series. We know this thing here is going to diverge. Well, if this thing is always bigger than this series, then this will have no choice but also to diverge. So the point is that natural log will be bigger than the number 1 for n being greater than 3. So this thing, because we know this is going to diverge, this is also going to diverge. So we are going to make use of this. Okay, so we are now going to make use of this. So hang on. So we are going to compare. We know nothing about this series. We are trying to determine if this series will converge or if it will diverge. But then we are going to make use of this. We know this thing here is going to diverge. We know it's going to diverge. We know nothing about this, but we are going to make use of something that we know about this series. So now let's check this. An divided by bn. So let this thing here be our an, and then let this thing here be our bn. So now we don't know what it's going to do. We're just going to get this divided by this. And see where the limit will take us. So we are going to get an divided by bn. So we're trying to determine the limit of an over bn. So this an divided by bn, this thing is the same. Well, dividing is the same as multiplying the reciprocal of this. So this top times top, bottom times bottom. That will then give you this. So when n gets, so here you've got one block plus another block. You've got one block plus another block. When n gets very big, this, because you've got n squared here, this block here will dominate this. So you can, when n gets very big, you can pretty much ignore this. Just look at this. When n gets very big, you're adding on an insignificant amount. So let's ignore this and just look at this. So now natural log, remember, so these two in a way cancel out, and then natural log will always be climbing. It will head towards infinity. So we know the limit. We know the limit of this will be infinity. So going back to here, hang on. We are trying to determine if this thing here will converge or if it will diverge. We know nothing about this, but we are going to make use of this. So let's try and see what happens when you get an divided by bn. When you get an divided by bn, it turns out that this whole an over bn, as n heads towards infinity, it turns out that it will head towards infinity. So now we've got this case here. It can't be this case because this case here is heading towards 0. It can't be this case here because it's heading towards some sort of constant. So it can't be this, it can't be this. So because an divided by bn heads towards infinity, we are going to make use of number 3. Well, number 3 here says that if bn diverge, then an will have no choice but to also to diverge. Because if you think about it, if this thing here diverge, meaning if the denominator is very, very big, then the numerator has to be also very, very big. It has to diverge. If it converges to, let's say, a 5, then you can see this is heading towards 0. So you've got this scenario here, or well, because the denominator diverged, then in order for you to have infinity, the numerator has to also to diverge. So going back to here, we know nothing about this, meaning we know nothing about this, but we do know that this thing is going to diverge. We do know that this thing is going to diverge. Therefore, the an will diverge. Therefore, this thing here will diverge. Okay.